So one circumstance in node voltage analysis that's really nice is if you have a fixed voltage source which connects to the reference node and then also connects to one of your unknown nodes that you're trying to solve for. And this is nice because in this circumstance, you can actually just write down what is that node voltage directly. So here V1 is just 100 volts, and we just read that straight off the circuit. So V1 here, remember, is the voltage of this node 1 with respect to the reference node, and that must be 100 volts just by virtue of that voltage source that we see in the circuit. So let's just go ahead and solve the rest of this problem as an example. So there's only one more node that I need to analyze, which is V2, or node number 2 over here. So I'm going to do Kirchhoff's current law at that node, so KCL at node 2, and this is what I will get. So I have V2 minus V1 divided by 10 ohms plus V2 divided by 50 minus 5 amps is equal to 0. So that's the equation that describes the flow of current into node 2. Now I already know the value for node 1, right? That's 100 volts. So I can actually just substitute that in directly. So V2 minus 100 divided by 10 plus V2 over 50 is equal to 5. And now I have one equation, one unknown, so I can just go ahead and actually solve this equation. So let's just clean up a little bit this fraction. So this is V2 divided by 10 minus 10 plus V2 divided by 50 is equal to 5. If I want to put those collect like terms on the V2, then I need to put them over a common denominator. So 5V2 divided by 50 plus V2 over 50 is equal to 15, bringing that 10 to the right hand side. So this will give me 6 times V2 divided by 50 is equal to 15, or V2 is 15 times 50 divided by 6. And I'll just grab my calculator and bear with me here. 15 times 50 divided by 6 is 125. So 125 volts is the potential for V2. So in the case that you recognize this pattern where you have a voltage source that just directly connects between ground and one of your nodes, really simple. In that case, one of your equations or one of your voltages can be just written down directly from the circuit diagram.